One set of engrams forms the foundation of everything you know how to do, the procedural knowledge behind every skilled action. Another set embodies what you know, your so-called semantic or declarative knowledge, from the world of concepts, ideas, and things. And yet another batch of engrams works in the service of your episodic memory, your diary of personal experiences, each tagged with a time and a place, when and where it happened. Functioning together, these engrams establish your individual personal perspective on life. But where exactly are these engrams? What is the anatomy of memory? The search for the engram began some 40 years ago with psychologist Carl Lashley. Using rats as subjects, Lashley trained them to learn mazes, then removed portions of the cerebral cortex and retested their memories. He found that memory suffered as more brain tissue was removed, but it didn't seem to matter what part of the cortex he took the tissue from. Lashley concluded that memory was not localized in any specific area of the brain. He may have been right for complex memories, but he was wrong about simple memories. Others continued in the search for the elusive memory engram. Among them was Richard Thompson of the University of Southern California. Using rabbits as subjects, Thompson has succeeded in finding one of the memory engrams by tracing the circuitry of the brain involved in conditioning and remembering. Thompson uses eye blink classical conditioning. A tone is synchronized with a slight puff of air to a rabbit's eye, which elicits a reflexive blink.
With a number of pairings of these two stimuli together, the animal develops a conditioned response, a learned response, a memory, if you will, so that it blinks to the tone before the air puff occurs. After the animal has been trained, we will then make a very small lesion in the region that we think contains the memory trace, and that very small lesion will abolish permanently the memory for this conditioned response. The memory traces for these learned responses that we study appear to be stored in very localized regions right here in this little structure within the cerebellum called the interpositus nucleus. This is a recording of the eyelid response itself. So time is going this way, tone comes on, and there's no response at all to the tone. Air puff to the eye, a reflex eye blink, eye closure, strictly a reflex before learning has occurred. The tone comes on at this point in time, and you'll notice that there is a very well-developed eyelid closure response that peaks about the time of onset of the air puff. There is then a reflex response to the air puff itself. This is the conditioned response. After the surgery, we can see that the memory for the learned response is completely obliterated. All that's left is the reflex response, the same response the animal gave at the beginning of training before it had learned the conditioned response. So we feel that as we come to understand how the brain stores memories, we will be able to develop new techniques and new tools to deal with memory disorders. So that's a very practical and I think now realizable goal.
Thompson's work was the basis for the research of Diana Woodruff-Pak at Temple University. Woodruff-Pak has pioneered the use of eye blink classical conditioning methods on humans as a means of detecting early onset dementia, such as Alzheimer's in older adults.
The idea that eye blink classical conditioning might detect Alzheimer's disease was derived from the animal model, the rabbit model. Scopolamine is a drug that impairs acetylcholine transmission. Acetylcholine is really the memory neurotransmitter. Alzheimer's disease devastates the acetylcholine neurotransmitter system. The reason that memory impairment is the #1 system of Alzheimer's disease is probably this acetylcholine connection.
Your ears, and you're going to feel some puffs of air in your eye that are going to make you blink. I don't want you to try to blink.
So my hypothesis was that patients with Alzheimer's disease would have this disrupted hippocampus, this impairment of the acetylcholine, and would find it almost impossible to produce conditioned responses, and that is the case. We have what we think is a perfect case study for our hypothesis. This individual started working with us as a good conditioner, and the first time we tested her, she had something like 50% conditioned responses, even though she was 89 years old. We saw her again a couple years later, and she had really dramatically slipped, and her eye blink conditioning score was below 25% conditioned responses. On the other hand, her scores on neuropsychological tests were normal and continued to be normal for another 5 years. So this was a case of an individual where eye blink conditioning showed impairment 5 years before tests that would be of declarative memory showed impairment. We're fortunate to have MRIs of this individual 5 years apart, and we showed about the time she had impaired eye blink conditioning, her medial temporal lobes were showing deterioration, and 5 years later, the MRI showed major deterioration in medial temporal lobes. It's critically important to detect Alzheimer's disease early, because even in the earliest stages, when there are no clinical signs, neurons in the brain are dying. So you want to catch the person as early as possible to preserve as much of their brain as you can. If we could catch a person and keep their personality and their memory intact, this would be the ideal goal. Of course, even a greater goal, I guess, would be to prevent the disease entirely.
Brain tissue atrophies. As more of the cortex is lost, so are the memories, then the personality, and eventually life itself.
Don't you remember? Things are so mixed up.
Life without memory is life without a past and a future. Throughout this program, we've looked at memory as the mind's most vital form of information processing. But there are many other higher order mental processes that make us what we are. Thinking, reasoning, planning, judging, deciding, problem solving. And they are all in the domain of cognitive psychologists who have transformed modern psychology. The Cognitive Revolution next time. I'm Philip Zimbardo.
Funding for this program is provided by Annenberg CPB to advance excellent teaching. For information about this and other Annenberg CPB programs, call 1-800-LEARNER and visit us at www.learner.org. To learn more about the Annenberg CPV Channel series and workshops for teachers, how to take them for credit, how to buy them on video cassette, call 1-800-LEARNER and visit us at www.learner.org.